multiplying two-digit numbers. Your learning goal is that I can choose a multiplication strategy and use it to multiply two-digit numbers. Let's take a look at an example here. They've given us a couple of different approaches to doing some math, and the crow is trying to figure out 24 plus 42, and so they do the math to say that 2 plus 4 must be 6, because they're adding up the tens, and then 4 plus 2 is equal to 6, so the sum is 66. And so then the wolf, or the coyote I guess, says, okay, well I want to do 24 times 42, so therefore I can follow the same approach that says 2 times 4 equals 8, and 4 times 2 equals 8, so the product is 88. What do you think? Do you agree with the strategy? Well, we can agree with the raven about the adding part, because basically they're adding up tens, and that works out. They're adding up tens, and then they're adding up the ones. But for the coyote, not so much. We can see for the crow that if we follow through 24 plus 42, adding up the 2 and the 4, that gives us 6, and the same here, the 2 and the 4 together gives us 6, so that gives us 66. But we know that if we're going to do the long division on the 24 times 42, we're going to end up with a much bigger number, because we're only, by just doing the 2 times the 4 and the 4 times the 2, that's not capturing everything that needs to be multiplied. Using our estimating approach, if I looked at these two numbers, I would say, okay, well, what if I estimated just something as simple as 20 by 40? And just doing that, I know that 20 times 40 is going to give me 800. So coming up with a number of only 88 tells me I'm way off in my calculations there. If we do a block rectangle diagram of 42 times 24, we could go through and see very clearly that there's a lot more than 88 boxes there, a lot more than 88 squares. Let's look at a new example. The students in Malik's class are each paying $29 for a field trip. So far, 17 students have paid. How much money has been collected? Solve the problem using your choice of calculation strategy and estimate to check your answer. The students in Malik's class are each paying $29 for a field trip. So far, 17 students have paid. How much money is being collected? Solve the problem using your choice of calculation strategy and estimate to check your answer. So for this example, we've got a model, and we say we've got 20 and 9. We've broken up the $29 that each of them is paying. And then there are 17 students, so that's 10 and 7. We can multiply that out. 10 times 20 is 200, 10 times 9 is 90, 7 times 20 is 140, and 7 times 9 is 63. So the area is 200 plus 140 plus 90 plus 63. So 200 plus 140 is 340, 430, 493. So $493 has been collected. In question 2, we're asked to create our own problem following the same model, but this time they want us to use the amount of money being charged to be something between 32 and 37. So I'm going to say they're each paying $35, and for fun we'll say there are 35 students. Now I need to look at what else I need to solve in the problem. So in order to figure out how much more money needs to be collected, first I have to figure out how much is collected so far, and then subtract it from the $2,000. So let's go ahead and do that. I'm going to create a model that's 35 by 35. Again, the exact dimensions don't matter. This is 30, that's 5. This will also be 30 and also 5. 30 times 30 is 900. 30 times 5 is 150. Same for here, and then 5 times 5 is 25. And now we need to add up the total. So we've got 900, so the area of this is 900 plus 150 plus 150 plus 25. So that's 900 plus 300 plus 25, which is 1,225. Subtract that from 2,000, and the amount left to collect is $775. How do you know the problem involves multiplication? Well, a possible answer to that is that you want to know how much money there is altogether, and there are 17 equal groups of money, so that means that you multiply. So we're dealing with equal groups again. How can breaking up the factors into parts help you to multiply? Well, we saw that multiplying 7 times 9, 7 times 20, 10 times 9, and 10 times 20 made it easier to multiply 17 times 29. So I can multiply those numbers in my head. So just as in the previous example, here 30 times 30, 30 times 5, those are easy numbers to multiply. So breaking things up into those smaller component pieces makes the multiplication easier. How would you break up 26 to multiply 26 times 40? There are more than one way you can do this, of course, but the most obvious example is to break it up into 20 and 6 and 40. You could have also broken it up into 25 and 1 and multiplied 25 times 40. So why is there always more than one way to multiply? There are always different ways to break up numbers that you're multiplying. For example, to multiply 14 by 27, you could calculate 10 times 27 plus 4 times 20 plus 4 times 7. Or you could break it up into numbers by its place value parts and multiply all the parts. 10 times 20 plus 4 times 7 plus 10 times 7 plus 4 times 20. It's really whatever you're most comfortable working with. Would you use the same strategy for both calculations before, and why or why not? So the short answer is no. So for 33 by 30, you can multiply 33 by 30 fairly easily because you can see that that's the same as 33 times 3 times 10, right? We've just broken the 30 up into the 3 times 10. So 33 times 3 is fairly easy. That's 99. And then you're multiplying by 10, which then just adds another 0. So you end up with 990. 12 times 14 is a little bit trickier. The numbers aren't as straightforward. Most people don't know their 14 times tables, and a lot of people aren't even necessarily comfortable with their 12 times tables. The solution proposed here is to say, well, 12 is double 6, and I can do 6 times 14 in my head. So I would do that and then just double my result. That's one way of doing it. I might also have said that I know my 12 times table, so I could do 12 times 12 is 144, and then I just need to add in 2 more 12s, which is another 24, so that would be 168. Or, of course, you can always go and sketch a diagram. Why is estimating the product a good idea? Well, it's easy to make mistakes, and estimating an answer should be a way to help you catch mistakes. If your final answer is way out of whack with your estimate, then you want to probably take a look at your final answer. Compare the strategies you use for 1-digit by 2-digit multiplication to the strategy you use for 2-digit by 2-digit multiplication. How are they the same, and how are they different? So they're mostly the same. You break up the factors into parts, and sometimes the parts are place value parts, but sometimes they're not. The difference is that with 1-digit by 2-digit, you usually break up only one factor, but with 2-digit by 2-digit, you usually break up both factors. Lesson summary. There are many ways to multiply 2-digit numbers. You could create a base 10 block rectangle with the factors as the length and the width. For example, to multiply 13 times 34, you have 3 hundreds plus 9 tens plus 4 tens plus 12 ones. Then you can add up all those pieces and you end up with the total of 442. You could multiply in place value parts and add the parts. You can use an area model to help you. For example, to multiply 13 by 34, you can see 10 plus 3 is 13, and 30 plus 4 is 34, so we've got 13 by 34. You can do the multiplication in the grid and end up and then add everything all together, and you end up with the result of 442. You can multiply in place value parts a different way. You could start with the ones and regroup as you go from right to left. So in this example, they're adding these numbers together first, then adding those numbers together second, and then totaling them all up to get the total. You could use an easier calculation or one that you already know. For example, to calculate 15 by 15, you might multiply 10 by 15 to get 150, and add another half of that, which is 75, to get 225. So it's easy to do the 10 times 15 and get 150, and then just take half of 150. If you remember that half of 150 is 75, you can do that, and then add the two together. To multiply 12 times 75, you could triple 4 times 25, which is equal to 100, and then triple it again. So we know that 12 is 3 times 4, and we know that 75 is 3 times 25. So we could do 4 times 25, and then multiply it by 3, and then multiply it by 3 again. We know that this is 100, and then it's easy to multiply by 3 to get 300, times 3 again, gives us the total of 900. Key terms. Area is the amount of space in a 2D shape, the number of 2D units that cover a space. For example, a rectangle that is 2 units by 3 units has an area of 6 square units. Factor is one of the numbers you multiply in a multiplication equation. For example, in 2 times 5 equals 10, 2 and 5 are factors of 10. Product is the result of multiplying. For example, in 3 times 4 equals 12, 12 is the product. Regroup means to represent a number in a different way without changing its value. For example, 12 can be regrouped as 1 10 and 2 1s. 10 tens can be regrouped as 100. Now it's your turn.